Hi folks, Mr. Long here. We're going to do a screencast, or I'm going to do a screencast about completing the square. Actually, I'm going to do two of them. One's going to be a preview of things you need to be able to do before you complete the square, and then we're going to start completing the square. Okay, so let's go here. So this is going to be about using completing the square to solve quadratic equations. And so the first thing I want to go over with you is what's it mean to actually solve an equation. And so first of all, really what it means is determine a value of the unknown that makes the left side and the right side equal. So here's an example. So what numbers or number can I replace x with to make sure that the left side and the right side are 0? So in this case, x squared minus 6x plus 8, and you might remember this from last year, it's one of those product and sum ones, right? So it has to multiply two numbers that multiply to 8 and add to negative 6, and you'd end up with x minus 4, x minus 2 equals 0. But I'm not worried about that right now. But the two numbers that work to make the left side and the right side equal are 2 and 4. So that's what it means. Those are called the roots of the equation. Of course, there's the graphical connection, which would represent these two ordered pairs right here, right? Those two ordered pairs, which are the x-intercepts, because we're saying that the y values are worth 0. Here's another one. What if we had this equation? What would this mean? Well, again, I'm finding the x values where x squared plus 12 would be equal to 7x. So what I did over here is I graphed them both. So x squared plus 12 might look something like that, right there. And then 7x would be a straight line through the origin, right? And then it would have two intersection points, which would occur right here and right here. Now those numbers end up working out to 3 and 4. Okay, so in this case, the roots of this equation represented x-intercepts of a parabola. And this, if I looked at this original equation here, the roots of that equation are 3 and 4. So the solutions to the equation are x equals 3 and x equals 4. They happen to be intersection points between 7x and x squared plus 12. Now, in order to solve that, we would have collected all the things on the left-hand side. Anyway, that just goes through what solving actually means. I want to talk now about perfect squares. And remember, you can pause, rewind. You should make notes on this as you go through. So let's begin. Ooh, that looks awful, doesn't it? My writing's terrible. Okay, so the first thing is, what does x plus 3 squared mean? Well, it means x plus 3 multiplied by x plus 3. And we've already done this, but I just want to go through it again with you. So it's an area model is what we're going to work with. So we're going to do x plus 3 multiplied by x plus 3. And that's what it means to be a perfect square, right? The length and width are the same. So in this box right here, we get x times x, which is x squared. And then in this box, we have x multiplied by plus 3, which is 3x. And then in this box here, I end up with 3 multiplied by x, which is 3x. And in the last box, it's 3 times 3, which is positive 9. Notice what a perfect square looks like. The diagonal will always have the same values. Okay, the diagonal will always have the same values, which in fact is, if we expanded that out and got our answer, it would be x squared plus 6x plus 9. So if you notice something, the diagonal entries are always half of the bx term, okay, of the middle term. So if we're representing things with a perfect square, these values right here will always be half of that bx term. Okay, let's take a look below. Let's see if we can do that. This one here. Now this one involves fractions, and that's one of the things going to be different about grade 11 is now you're going to have fractions in completing the square. It's going to be very important for you to get a calculator that you can use that has fraction buttons on it, and it has to work really well. I'll show you how it works on the calculator that I use on my iPhone and iPad, but it works exactly the same way in the black calculator. So again, let's multiply this out. I've got x multiplied by x, which is x squared. And then I have x multiplied by 2 over 3, which is 2 over 3x. Since it's a perfect square, I'm going to get the very same entry there, 2 over 3x. The final entry is going to be 2 over 3 multiplied by 2 over 3. So our exponent rules say that we have to square both the 2 and the 3. 2 squared is 4, 3 squared is 9. Now I can do that on my calculator if I want. So I put things in a fraction, and I do 2 over 3, and I probably should have put a starting bracket and an ending bracket, and then square it. And it gives me a decimal. Now there's a button right beside the equal sign, and you'll have a similar button like this in your calculator where you go back and forth between decimal and fractions. So you can see that 0.444 is the same thing as 4/9. Okay, 0.444 is the same thing as 4/9, which is what we got anyway when we did it. Okay, so we've got 4/9 there. Now if I'm to add that together and get a value, I'm going to have to add the diagonal. So I'm going to get x squared plus 2 is 4. So 4/3 x plus 4 over 9. Okay, so, and remember then again this idea that the diagonal entries are exactly half of the b value. So what's half of 4 over 3? Well, it's obviously 2 over 3, right? Okay, so let's now go through the idea of actually completing a square. So this is all of this stuff is stuff to help you understand how to complete the square, prior knowledge, if you will. So let's figure out what we need to do to complete the squares for these. So if I've got x squared plus 10x and I want to complete a square, what do I need to do? Well, I know I'm going to have an x squared here, and I know I have to split that evenly if it's going to be a square. So I divide that by 2, which is going to be negative 5x, negative 5x. I have to split it evenly. I'm dividing by 2. That's b over 2. Now, what I know the outside is going to be like is x minus 5, x minus 5. So this is the entry here where I literally complete the square. If I'm going to make that square complete, it's going to be negative 5 multiplied by negative 5, which is plus 25. So that's what was required to complete the square. Let's look at this one. I should probably have a blank there. And we kind of just did this one. But now if I have x squared plus 4/3 x, I need to complete the square. Okay, so the first thing I'm going to do is I know that's going to be x squared. I have to get half of 4/3. Well, how do I do that? Let's see with our calculator. I'm going to divide by 2. So again, put the fraction button, 4/3, and then divide by 2. Okay, that's really important. So your calculator can do this for you. 4/3 divided by 2. Well, it's that decimal component there, but I can go back and forth and make it 2/3, right? And again, you should have this feature on your calculator. So 4/3 divided by 2. I'm taking half of 4/3, which is 2/3. Okay, so that means then to complete this, I do half of that number, which is 2/3 of x, 2/3 of x, and now this is x plus 2 over 3, x plus 2 over 3, and if I complete the square, it's going to be 2 over 3 squared. Well, if I square 2 on the top, I get 4, and if I square 3 on the bottom, I get 3 times 3, which is 9. So it required 4/9 to complete the square. Okay, and again, you may want to look over that. I'm going to go down to the next thing. So sometimes we need to keep fractions in answers, and when is that? And again, this is more just prior knowledge. When is it that I have to keep a fraction in an answer to prevent rounding? Well, let's look at some fractions. Are 1/2 and 0.5 exactly the same thing? Absolutely. It doesn't. We don't have to round. What about 1/3 and 0.333? Are those the same thing? Actually, they're not, because it's 0.33333 forever. So it's what we call a non-terminating decimal. So if you get something in thirds and you want to have the exact answer, You cannot convert to decimals. Okay, what about quarters? Will quarters convert nicely to decimals? Yeah, if your calculator, if you do 1 divided by 4, you get 0.25, and it terminates. It means it ends. So 0.25, the decimal is over. What about fifths? Well, that's easy. If you do 1 divided by 5, you get 0.2. It's a terminating decimal. So if I have 1/5, I can write 0.2. It's the same thing. What about 1/6 or 5/6, right? Or something like that. Well, if I've got 0.16666 forever, it's a non-terminating decimal. So if I'm representing things in 6, I can't convert it to decimals, right? 1/6, I'd have to leave it as 1/6. What about sevenths? Well, sevenths are 0.142, blah, 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 blah. Okay, it's again non-terminating decimal. So if I just write 0.142, that's actually not exactly the same as 1/7. So I'm rounding, and I'm trying to avoid rounding. So if I'm working with sevenths, I have to keep the 7 in the denominator. I can't convert it. 1/8 converts perfectly to 0.125. It's a terminating decimal, so I can use either 1/8 or 0.125. When I go to ninths, 1/9 is worth 0.111. And it goes on forever. So if I just use 0.111, is that exactly the same thing as 1/9? No, it's not. So if I have 1/9, I can't use that. So you can see here that in many cases you're allowed to convert a fraction to a decimal, but in some cases we're not going to do those conversions because we're rounding. In grade 11U, we want to work a lot more with exact values, right? We don't want to have to round where possible. Now we are still going to do some rounding with square roots, but with fractions we don't want to do any rounding. Okay, so I'm going to pause that there. That's the screencast for introducing all the skills that you'll need for completing the square. And then in the next one, I'm actually going to solve quadratic equations by completing the square. Again, rewind, review as needed. Oh, and make yourself some notes.